Okay, so we're going to go the opposite direction now. We're going to find the inverse trigonometric ratios. Okay, inverse trigonometric ratios, as I stumble over my words here. Okay, so we got a right triangle, and A is going to be an acute angle in that right triangle. So for inverse tangent, well, if tangent of A equals x, then inverse tangent of x equals the measurement of angle A. Inverse sine. If sine of A equals y, then inverse sine of y equals the measure of angle A. Inverse cosine. If cosine of A equals z, then inverse cosine of z equals the measure of angle A. Okay, important comment about that -1. It is not an exponent, all right? So let's go take a look at our good friend cosine. So the -1 tells us that it is an inverse function, not a reciprocal, right? That -1 on a plain old number tells us, oh, you're going to do the reciprocal, right? It's an exponent. But that -1 in that position on a function is telling us that it's an inverse function, right? And so we can call this arc cosine of x, right? So arc cosine means the arc that creates the ratio. If the vertex of an angle is at the center of a circle of radius 1, the arc is the same measurement as the angle. We'll venture into that down the road, all right? Now, if you did want the reciprocal, if you actually wanted 1 over cosine of x, that is one of the other trig functions. It's called secant of x. All right, so if you want the reciprocal of cosine, you want the secant. If you see the cosine to the -1, that means inverse function, and you're looking at the arc cosine. You'll notice sometimes I say inverse cosine, sometimes I'll say arc cosine. Same with the sine and tangent functions. Okay, so let's find an exact value. Ooh, we want the inverse tangent of √3, right? It's like, hey, the inverse tangent of √3 equals theta. Well, I know tangent of theta is opposite over adjacent. And I know opposite over adjacent has to equal √3. Oh, I can make that a fraction. I just put a 1 underneath. √3 over 1. So the opposite side is √3. The adjacent side is 1. And of course, our helpful cows are constructing a right triangle for us. Pingu is going to bring theta in for us. And the airplane cow just dropped the right angle for us. Right, I need a right triangle. And I don't know anything about, A, B, or C. So it's like, hey, we're looking for theta. I just got to put theta in one of the acute angles. Doesn't matter which one. So say, okay, now I can start working. Opposite over adjacent. So √3 has to be opposite. 1 has to be adjacent. So opposite of theta, I need the square root of 3. Adjacent to theta, I need that 1. Now, when I start drawing these triangles, I don't know ahead of time what side should really be like the shortest side, right? Or if the two legs should be kind of close in length or very different in length. So I don't ever find myself getting concerned about that if I'm just doing a quick sketch, right? Square root of 3 is actually like 1.732, right? Or here I got it rounded off to 1.73. So that's not quite twice as long as the number 1, but it is significantly longer. But if you look at the picture here, it looks like the square root of 3 looks like it's a shorter leg. Don't worry about it. Okay, let me see. A squared plus B squared equals C squared. We're missing the hypotenuse, so we're going to have to look for C. Since the triangle is not labeled with letters, A and B are interchangeable. Either one of those could be side A, either one of them could be side B, does not matter. Right? And of course, we're going to get c squared equals the 4. I take the square root and I get 2. So the hypotenuse is 2. Hey, 2, you got to get over the hypotenuse, please. Okay, there goes 2. So we've got a triangle. It's a right triangle. The side opposite theta is root 3. The side adjacent to theta is 1. Those are the legs, of course. Hypotenuse is 2. 1 and a 2 and a root 3. We know this triangle, right? This triangle is a 30, 60, 90 triangle. And we know that root 3 is across from the 60-degree angle. All right, so that is how we can find the inverse tangent of root 3. All right, so it's time for the worksheet. We're going to go through and find some inverse trig function values. Oh, surf's up. I think that was overly dramatic because it looks like calm water. There we go. There's a callus surfing a little bit more calmly and coolly. There we go. Off to the tropics, it looks like.